Today we're going to be talking about multiplying a two-digit number by another two-digit number using the area or array model. So we're going to multiply 24 times 35, and when I'm thinking about area or arrays, I'm thinking about rectangles. And as you see, we have one gigantic rectangle here. And I know that finding the area means that I'm finding how many little square units are inside of my big rectangle. And to do that, I have to multiply the length times the width. So when I look at the rectangle that's in front of me, I see the 35 columns and 24 rows. But those are not friendly numbers for me to work with. So I'm going to get rid of them and split them up into something that is easier for me to use. So we're going to start by breaking our rectangle. So here's my big rectangle, and I'm going to break it into 4 equal separate pieces. So we're going to start, we're going to make a rectangle here. So this is one part of the product. This will be another part of the product. Then we'll split this to make a third part of the product and another one to make the fourth part. So recapping, I've got one part of the product, 2 parts of the product, 3 parts of the product, and 4 parts of the product. So now we just need to label what those parts are or how much they represent. So if I look here, if I look at this top rectangle, this big one, I'm going to look to see how many rows do I have and how many columns. So if I'm looking at my rows, I've got 20 rows going across and 30 columns going up and down. Then I look to my next rectangle. I'm looking for rows and columns. So I have 4 rows and I have 30 columns. 4 rows going across and 30 columns that go up and down. So if I'm looking, I have 10 columns, 10 columns, 10 more columns. It's going to be 30 in all. Moving over to my next rectangle, I've got 5 columns, 5 that go up and down, and 4 going across. So 4 rows, 5 columns. Then the last rectangle, I've got 20 rows, 2 tens, and I've got 5 columns going up and down. And if you notice, the numbers that we labeled are the same numbers that we started with, just in expanded form. So I've got 35. 30 plus 5 is equal to 35. That's one of the numbers I started with, and it's the same across the bottom. So I'm putting that number in expanded form. I also have 24 in expanded form, so 20 rows and 4 rows. So really all you have to do is put both of your numbers in expanded form. So now we're going to be doing the multiplying part. So we're going to start down here at the baby box. We're going to do 4 times 5, because remember, area means length times width. So rows times columns. 4 times 5 is 20. And then we are going to do the 5 times 20. I don't know 5 times 20, but I do know a fact that will help me. I know that 5 times 2 is equal to 10. And I have 1 0 in my problem, so I'm going to put 1 0 in my answer because I don't have 2, I actually have 20. Then I'm going to do my next smallest box, which is the 4 times 30, or 30 times 4. And that is not a fact that I know off the top of my head, but I do know 4 times 3 is 12. And if I have a 0 in the problem, I'm going to put a 0 in the answer. And then finally, my big box, I'm going to have the 20 times 30, or 30 times 20, and I don't know that fact right off the top of my head, but I do know 2 times 3, which is 6, and then I'm going to count how many zeros I need. So I need 1 0, 2 zeros, 1, 2. So 30 times 20 is equal to 600. So now I have 4 partial products that I need to put together to figure out the final product. So adding my partial products, I'm going to take the 600 plus 100 to get this to be 700. So the top 2 rectangles were 700, and then my bottom 2 rectangles were 120 plus 20. And I'm adding them together because I want to know the whole thing all together. So now I'm going to add 700 plus 140 to get my total for the entire rectangle. So the answer to 24 times 35 is 840. So the blocks are wonderful to help me visualize what a multiplication problem would look like, but we're going to run out of blocks, and you don't get to use blocks very often. So we have to be able to do this without the blocks. So we're going to follow the same steps, but we're going to do it without. So we're going to start by making a nice big rectangle, and we're going to write each of the numbers from the equation in expanded form. So I'll start with 54. So I'm going to put 54 in expanded form. The value of the 5 is 50. The value of the 4 is 4. So if I write it on the top, I'm going to write it on the bottom. And anywhere I see a plus sign, I'm going to draw a line to connect them. Then I'm going to put 28 in expanded form. 28 in expanded form would be 20 because the 2 is worth 20 and the 8 is worth 8. So I'm going to put it on both sides because if it's on the left, it's on the right. The rows and columns are not going to change from one side to the other. And having them on separate column or on separate sides is going to help me kind of keep track of what I'm multiplying. So now this is still the area model, so I'm finding the area of each of my partial rectangles, of my partial product. So I'm going to start with my small box, the ones column, because in math we always start at the ones. So I'm going to multiply the length times the width, which 4 times 8 is going to be equal to 32. Then I'm still sticking with my ones. So I'm going to do 4 times 20, but I don't know 4 times 20. But I do know 4 times 2, which is 8, and it's not actually 4 times 2, it's 4 times 20, so I'm going to take that 0 from the problem and put it in the answer to represent all those tens. I'm going to move over here to my 8 times 50, length times width. I don't know 8 times 50, but I do know 8 times 5. And I picked this specifically because you have to be very careful when you have 5s or 50s, because what happens is you have 8 times 5 is 40. Some people see that and say, oh, it already has 1 0. But no, that's the 0 from the 8 times 5. So you still have the 0 that makes the 5 a 50, the value change. So we have to add another 0 on to represent all of the tens. And then we're going to go to our final box. Whoops. The 20 times 50, and again we're being careful because we see a 5 or a 50, so I don't know 20 times 50, but I do know the fact 2 times 5, which is 10. Now again we're being very careful because I see a 0 there. That does not play a factor in counting my zeros because that's just the answer to my fact. I still have 2 zeros to represent all of the tens that were in the problem. So 20 times 50 is really 1,000. So now I have 4 partial products. I want to know the area of the entire rectangle. So I have 4 parts. If I want to put them all together, I'm going to add them up. So I'm going to take each rectangle, each part, and add them together. So I'm going to do 1,000 plus 80, so the top 2 rectangles, this one and this one, and I'm going to get 1,080. I'm now going to add up these 2 rectangles, the bottom 2 rectangles, 400 plus 32, and I'm going to get 432. But I'm still not done because I have an area of this rectangle and an area of the top rectangle. I don't have the full rectangle yet. So now I'm going to add my two sums together to get the total from all the partial products. So the answer to 54 times 28 would be 1,512.